Hello, this video is about calculus and sequences and series. This first video shows a ball bouncing in front of a wall marked in meters. We will be explaining the total distance the ball travels using an infinite geometric series. Here the ball is dropped from 3 meters. It then bounces to 2 meters and then bounces just above 1 meter. We will use these points to derive our geometric series because further measurements are inaccurate. Using our data after several trials, we found that the first bounce was consistently between 1.75 and 2 meters, and the second bounce was within 20 centimeters of 1 meter each time. So first off, we'll start by reviewing the standard form for a geometric series, which is the sum as from n equals 0 to infinity of c times r to the n, where c equals our starting value or starting height, and r equals the ratio or rate of change. So, because we started with our ball, and we dropped our ball from 3 meters, and then the first bounce was less than 2 meters, and then our third bounce was just greater than 1 meter, and so on, we decided that our rate of change, our R value, was closest to 5/8. So using this to get into this form, we know that we have our starting height. If we multiply that by 5/8 to the 1, that gives us this next height. And if we add 3 times 5/8 to the 2, that gives us this next height, plus 3 times 5/8 to the 3, that gives us our next height, and so on. So that we can put that in the standard form, the sum of n equals 0 to infinity of 3 times 5/8 to the n. But we also have to take into account that since this first drop, it only goes downward, the next time it goes up and then down that distance. So we have to account for these upward and downward, so we need to add 2 into all of these, which means that our equation to find the total distance traveled will be the sum of n equals 0 to infinity of 6 times 5/8 to the n. But also, since this is starting at 3 and it's not going up and then down, it just has one distance at the 3, we have a -3 out in front. So this right here will equal the total distance traveled. Total vertical distance traveled. So then to find what our answer is, we're just going to use this formula, which is c over 1 minus r, just using these numbers based off of this right here. So that is going to be 6 over 1 minus 5/8. And this is just a standard formula to find the actual total distance based off of this geometric series. So we'll simplify this. It will be 6 over 3/8, flip and multiply, equals, this is 8 over 3. So we have 48 over 3, which equals 16. But then we have to remember this minus 3 here. So our final answer is 13 meters of total vertical distance traveled by the bouncing ball. In conclusion, we used a geometric series to find the exact distance traveled by the ball. However, because we used estimations for our data points, we can confirm that there is a significant margin of error in our results. Thank you for watching.